Right, today I have this Polaroid P40 LCD 12. It's a Vestel set, and the fault with it, like many Vestel sets, is I plugged it into the wall. You get no standby LED on there. If you press the button, you hear the button cheeps. So we're getting 5 volt standby, but the set's not coming on. Why is that? Now this uses a 17 PW82, and I've seen the same failure occur on the 17 PW26. So depends which one that's used in here, but and I've done a few of these, as I said. I've done a 32-inch sharp with the same fault, a 40-inch sharp with the same fault, and the fault, what I'm guessing is there's 2 diodes on the power board that are for the PFC boost converter, and they don't short circuit, but one of them goes leaky, so it doesn't rectify the current properly, and it goes leaky. It has leakage current across it, which you can use your multimeter to test it. So and I'm gonna see if it's the same fault. It's just a prediction, but either way, this is going to be a repair video on this 17 PW82 power supply. So I'm going to take the back off this TV and have a look inside, and then we're going to start testing it. So here's the inside of this Polaroid 40-inch LCD TV. It uses a 17 PW82-3 power supply. Vestel, of course. Its main board is a 17 MB90-2. LCD module's a crap-ass Samsung HM07. Very bad panels, so I expect the LCD panel will fail in this prematurely in a few months, but I'm going to fix the power supply for now at least. Now, the 2 diodes that I'm talking about are these 2 here. They are MUR460AX, I think. And they don't short circuit, they fail leaky, so they let leakage current through. So I'm going to test these on video. And I have another, this is a 17 PW26-4, but it's a very similar design. This one's just a bit newer and a bit bigger. And it has the same diodes on there. And I'm going to test them on video, so you can just get an idea what the fault is. I'm going to set this up in a way that you can see the meter. So my meter, I have a diode mode, which is that. And when it detects a short circuit, it beeps. I hope you can see that. Okay. Now these 2 diodes are for the PFC. You should not see any leakage current across them whatsoever. So to test the diode, you put your black lead where the sort of grey stripe on the diode is. So we're getting about 360 millivolts, and we shouldn't see a reading that way. Now actually, it appears these are actually good, which is quite a shock to me. And on the other supply I have here, just to show you here, I'm going to test these 2 diodes. You shouldn't see a reading when you reverse the polarity of it. Okay, so those diodes aren't failed. So now I'm going to check the other 2. There's 2 diodes there. I'm going to check for voltage drop across them. And because I have read up, they can actually cause this issue. So, and that's a dead short across there. And I think that's our problem. So yeah, there's our problem right away. one of these two diodes is short circuit. And on these Vestel power boards, it's nothing uncommon. They are, in my opinion, the kings of blowing up diodes, especially on their newer LED ones and the 17PW25 supplies, and even these ones. They have a habit of making diodes have a meltdown and not work properly. And it's on the older supplies like the 17PW20 and the 17PW16. I don't think I've ever seen a diode on them fail. But on the 17PW, I'd say 26.4 plus, I've seen Vestel kill a lot of their diodes, and I just don't know why. Now I'm going to show you a trick. If you have an ESR meter, it can actually help you find which one of these two are bad, because these are in a parallel here. So if one is shorted, both will show up as shorted. But you can use an ESR meter to find out which diode has the lowest ohms reading across it, and then you can cut it out of circuit and remove the dead short, and then you should be able to power on the TV. So I'm just going to get my ESR meter quick. You can do it with a multimeter on the ohms range, but it's not as accurate as an ESR meter, but you can do it. Just put your probes directly across one of the diodes, and whichever has the lowest reading to 0. So say one diode has 150 ohms across it, and then another has 149 ohms across it. The one with 149 will be at fault. So I'm just going to get my ESR meter because it's a lot more accurate. Alright, so what I have here is my Peak Atlas ESR meter, and it's got the two crocodile clip probes on there. So I'm just going to hook them up across these diodes, and I'm going to see what ESR this thing gives. So we've got 0.8 ohms on the one here. So now we're going to remove the probes off there. And 0.7 ohms across that one. So that one is likely the one causing the issue here. So we're going to turn that off, and this one is going to be snipped like so. Alright, I'm going to set the camera back up, and we're going to take our multimeter again. Again, you can use your meter in the ohms range to do this. I'm going to set this to diode mode. I'm going to check for short circuits again, and as you see now, the short circuit has gone away. So we've removed the defective diode out of circuit, and I wouldn't recommend you doing this, but you can actually run the TV with just one. I've bodged that up somehow. I'll take that out in a second. But you can run the TV with just one diode just to test it and just make sure the rest of the TV is good, and then you can order replacements, because you can't just leave that one in there, because you're just going to overheat it, because it's going to be having to do the other diodes work as well as its own. So I'm just going to take that out there and plug in the TV and see what happens. So that diode is out of circuit, and then we're going to plug the TV back in, and standby LED. Press our little button, begins to boot up with its little flashing sequence. Backlight is up, and just verify that the screen is all good, which it is, and I can actually hear the power supply whining probably because that one diode isn't in. It's getting pretty warm actually. This might not be your case. It might not be one of those two diodes that are shorted. It could be one of these two. These don't tend to go short circuit in my experience. They go leaky, so you want to check those as well if you have no standby. But if one of those does fail and you just hover your hand over it, you can feel an enormous amount of heat coming off of them if they are failed. With that, the power supply will refuse to start any of the other voltage rails. So now I'm going to get the part number of this diode. It's UF5402. I think I've got some of those in stock. I'm going to replace the pair of them as well, not just the one, because Vestel basically don't design the circuit properly and they expose the diodes to a higher voltage than they can take on startup than what they're rated for. Then over time it just makes them have a meltdown and go short circuit. So you want to replace both the diodes if you do have any issue. I'm not going to replace those two because they are actually, it's rare that they do fail on these. But let's see if I've got any of those in stock, and I'm just going to message the customer and let him know on the fault. One other thing I'd really recommend whenever you get one of these 17 PW82 or 17 PW26 power supplies is you want to look out very carefully for the caps that are used on there. If you see one that has this brand which says Chang on it, or if you see one that has these green capacitors that say Samson on them, SAMXON, or if you see any that have these, one with this 3 style vent and that say G-Luxon on them, you want to replace them because they're known to be defective, which leads to these supplies failing. Try and get a shot of the brands there. Luckily this supply uses Elite, a Hashi and a HEC capacitors. They're not the best caps in the world, but they're certainly not the worst ones. They rarely fail, and those caps will by sure outlast the rest of this TV, but the ones on these that are green, purple and black that say Chang on them, you want to get rid of them straight away. The primary unit is fine on all of them. I've only ever seen one primary cap fail on the 17 PW26, but you want to replace the secondary side caps if they are any of the ones that I've just stated, because they have a habit of blowing up. So, and if you don't want to be taking this thing back apart a few months down the line, I suggest you replace them, but it's up to you. So I'm going to take this out and we're going to find some diodes. Okay, so I'm just going to show you how to replace the diode. Also, if you've been soldering for a long time, you pick up a few tricks. I only need a soldering iron and some solder. So you get this fixed, and I have 2 diodes that I've bent the legs into position. They're both UF5402s. What I'd recommend is that you snip one of the leads off the diode and just fold it up like that. Find the 2 solder pads on the board. Just take your soldering iron, just clean the tip, heat the pads there, and just push the legs of the diode out, and make sure you have a pointy tip. You can't do it with any other type. You probably could, but I've never tried it. And you just literally push your iron through the hole, and you clear the hole instantly, like so. I'm just soldering on my carpet here because I can't be bothered to go anywhere else, but afterwards you just pick up the old legs and the diodes and you just chuck them away. So you'll notice on the circuit board there's a negative stripe, and on the diode there's a grey stripe. That's basically where and how you polarise them. So the grey stripe on your new diode goes where the grey stripe on the circuit board is. And you do one at a time because it's a lot easier. You just push the legs through and use your one finger on the other side of the board to support the diode and your other to feed the solder. You're just going to add a bit of solder to one of the pins, not both. And I don't know if you see what I did there, but I let it drop out, and that's a reasonable height. It doesn't look that tidy, but it's going to work anyway. So we're not going to solder the other leg just yet. Just going to get the other one in. Whoops. Make sure you polarise them correctly, because it won't blow up, it just won't work, because you can only feed a voltage and a current through a diode one direction. So this one's been a bit stubborn to get lined up, so I'm just going to apply a bit of heat. There we go. Now what you're going to try and do is get them as close to each other as you possibly can, and do that whilst you're soldering it, because what happens is they normally tend to fail is one ends up taking more heat, which means it has a lower bias across it, so it takes more current and it just gets hotter and it destroys itself. That's what you get when you parallel diodes like this. And also you're working on a power supply, so you want to make sure you discharge the filter cap. And for some reason my iron isn't melting the solder as good as I'd like it to be. I think the plug for my iron has come out. Here it has. So I'm just going to have to let that reheat again. And it's a cheap extension cord, that's what happens. It takes a few seconds to heat back up. But yeah, you see I've sort of got them as close together as I can, and it doesn't look too bad at all, and I've got the polarity all correct. And as I said, none of these caps need to be changed either, it's just literally the two diodes. And one thing I'm going to do is, you see these two that are for the PFC, because I'm not going to smash the camera, is I'm just going to clamp these a bit close together and try not to break the solder joint at the same time, just so that one doesn't get hotter than the other, because that's when you get failures. So I think my soldering iron's back up to temperature. Here it is. Okay, so now we're going to solder the other legs. And it's easier to use this method because you don't have to apply a ton of flux like I see many other people who solder do. And the chances of you breaking a pad, if you're pretty experienced, is pretty much nil when you use this method. But if you're new to soldering, I'd recommend that you have a solder wick or a solder sucker if you're doing a method like this. But just going to flow a decent amount of solder on there. Make sure the diode's got a good contact area. This will be fine, and I'm just going to reflow the joints on these two that I just clamped together, just so that they're not going to break apart or break off the board even. Now, of course, only heat one leg at one time, because if you heat both the legs, the part's just going to drop off the board, and you're going to have to resolder it and clean the pad again. So those are in solid. Then you take your side cutters and you just snip the excess legs off there. Just get rid of those. And it's flux residue free. And it's taken a few seconds to replace those. So now I'm going to put this back in the TV and give it a try. Alright, so got those two new diodes on there, got my initial on everything. So now I'm going to give it a test. Now before you seal up the back cover, you're going to want to just make sure it all works. So get the standby out. Find the little button there. And I've noticed now that I have two diodes there, the power supply isn't making that little whining noise it was. The backlight is on. And there's the no signal frame. So before I do anything, or seal anything up, I'm just going to run it for a little bit. And then just make sure it doesn't cut off randomly and fault out again, but likely it won't. It should probably be okay. and then I'm going to show you something else I do on these Vestel sets. Okay, so I've sealed the TV up, and I'm just going to show you a few other things I do on these Vestel TVs whenever I get one. It's got my little Vestel remote here, which I use for all of them. Good thing about Vestel is you can use any series remote on any of their TVs. So now it's booted up. Let's get the hour count on this TV, and to get into that you have to go into the service menu. It's 4725. 463,200 minutes. That's roughly, say, about 8,000 hours, 8,500 hours or so. That's not that long if you think about it. But now what I do is I go install and retune. First time installation. And I totally retune it and everything, because these do develop bugs with the firmware, especially the newer ones, the LED ones. The firmware will lag out, and it won't work properly. So, and even on these older ones, it's best just to retune them, because I've had it where the firmware glitches out and you get no sound, or you know, the pitch is distorted or whatever. I'm just going to tune all this in, and then we'll do a final overview.
Want the trees gone.
Come the summer, these branches grow.
Right, so I've just reset it, so I'm going to go into the picture option. I'm going to set this to dynamic. And I'm going to go to backlight, and I'm going to put it on low. Even on the LCD versions, I put the backlight onto low. Because it's less stress on the inverter and less stress on the power supply. I'm not sure how many watts it ends up saving by turning the backlight down, but it's got to be a fair few. I'm just going to turn the dynamic contrast onto low as well, or medium or so, which, believe it or not, actually will reduce some of the stress on the LCD display. And just noticed that this video is actually in my local area that's on the news right now.
A detective's been cleared of giving a missile.
Yeah, that's a repair of a 17PW82-3, but it applies to all models, and the 17PW26 just discussed some of the other faults that can occur. Alright, so thanks for watching, see you in the next one.